Hello once again, pre-calc students. This is Mrs. Y speaking. We'll be talking about our 4-3 lesson today, which is about the remainder and factor theorems. There are some things to remember. We're going to talk about the remainder theorem. The synthetic division is one thing that we use to solve some equations and some problems. And we'll also be discussing, once again, that factor theorem. So now moving on to the remainder theorem, it states that if a polynomial p of x is divided by x minus r, the remainder is the constant p of r. So now taking a look at our first example, it states 2a to the fourth plus 3a squared minus 5a plus 2. Now if we divide that by x minus 2, what would the remainder be? Well, first we need to pick out what our r is. Here our r is that 2. So now, by plugging it into our polynomial, so p of 2 would be 2 times 2 to the fourth plus 3 times 2 squared minus 5 times 2 plus 2. Simplifying, that will give us 32 plus 12 minus 10 plus 2, which then should give us 36. So the remainder would be 36. Now, synthetic division. Now what it is a shortcut for dividing a polynomial by a binomial of the form x minus r. So here, taking a look at our example, we want to take x cubed minus x squared plus 2 divided by x plus 1. Now to do that, we first want to write this 1 over here. You guys might be familiar with this. I've seen some of you do it before. So then we create this box. Now we want to look at what our coefficients would be in front of our polynomial. So here, 1 would be our x cubed. In front of our x squared would be a negative 1. And then notice now we don't have an x term. So in place of that coefficient for the x term, we just write 0. And then we have the 2. Now to solve this, we want to take this negative 1. We want to drop down that first term. So negative 1 times 1 would give us a negative 1. So we write that over here in the next spot. Then negative 1 minus a negative 1 is negative 2. Negative 1 times negative 2 is a positive 2, so we write that over here. We add those two terms together, drop our 2 down. So negative 1 times a positive 2 is a negative 2. Bring that over here. 2 minus 2 is 0. So the quotient, or our answer, or solution, would be x squared minus 2x plus 2, with our remainder being 0. So we know that we can write it in this kind of form by looking at our coefficient that we got in our quotient. So this 1 would be in front of the x squared, this negative 2 would be times the x value, and this positive 2 would just be our a regular coefficient or number. Moving on to another example, it says use synthetic division to find the remainder of x cubed plus 4x squared minus 3x minus 5 divided by x plus 3. Now we want to rewrite our coefficients once again, just like how we did last time. So we're dividing by x plus 3, so our r would actually be a minus 3. Write our box here. So a coefficient in front of the x cubed is just 1. Coefficient in front of the x squared is 4. In front of our x is a minus 3. And then we have a negative 5. Alright, let's go through and start this process over again. So we first want to bring down our first coefficient. So negative 3 times 1 is a negative 3. 1 times a negative 3 is once again negative 3. Negative 3 minus 3 is negative 6. Negative 6 times a negative 3 is a positive 18. When you add those two together, you should end up with 13. Now we want to write our final sum that represents the remainder. So the remainder here would be 13. Now to write our quotient, it would be x squared plus x minus 6. So that's just another example of how we do synthetic division. Finally, now moving on to the factor theorem. The factor theorem states the binomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. So that big key here is if and only if that p of r equals 0. So example states, use the remainder theorem to find the remainder when 2x cubed minus 3x squared plus x is divided by x minus 1. It says state whether the binomial is a factor of the polynomial and explain. Now to see if x minus 1 is a factor, we need to plug in our r value into our polynomial. So plugging in our f of 1 into 2x cubed minus 3x squared plus x, that should give us 2 times 1 cubed minus 3 times 1 squared plus 1, which should get us 2 minus 3 plus 1, which equals 0. So f of 1, or our p of 1, equals 0. So since the remainder is 0, the binomial x minus 1 is a factor of the polynomial by the factor theorem. Now we're going to move on to our final example here for the day. It says determine the binomial factors of x cubed minus x squared minus 49x plus 49. Now recall in our first two lessons we talked about the degree. So here we can see that there should be 3 roots to our equation. Now knowing that, we can actually type this in, this equation, into our calculator. While doing so, you can eventually kind of see that our graph would do something that looks like of the sorts like this. Now you can go into your table setting in your calculator and you can try to see where our our y values would be 0. When we do that, we actually can see that our it crosses at negative 7, positive 1, and positive 7. Now that's actually going to be our roots. As you recall, our roots, or sometimes we have our real roots, real solutions, and that's where it crosses our x-axis. So here, our roots would be negative 7, positive 1, and a positive 7. Now recall once again that our factor is that x minus r, x minus our root. So here our factors would be x minus a negative 7, which turns into a positive, so x plus 7, x minus 1, and finally x minus 7. So another note is that factors are always found by taking x minus the root. Once again, that's just that recall here. Well, I hope you guys enjoyed this 4-3 lesson. If you guys have any questions, once again, you can see me inside my office before or after school, or we can set up a time. Otherwise, we'll see you in class tomorrow.